Hello everyone, welcome back to my channel, and we have a new video today, which is follow properties of ratio. In the past video we have discussed the properties of ratio, and we have just discussed two properties of ratio. Today we're going to discuss another two properties of ratio in this video. If you haven't watched the last video of yesterday, you can just very easily, I'm going to leave a link in the description box below for the video of the properties of ratio, because you need to know the properties of ratio, the first part, to know this part and proofly and easily understand it. So let's go to follow properties of ratio, and it's another grade 6 lesson. What are the properties of ratio? So we have discussed two properties in the past video. So in the past video we have discussed two properties of the ratio. Today we're going to discuss another two properties. So property number 3, to compare two quantities using ratio. So this property is going to show us what to do when we compare two quantities using ratio. They must have the same unit. Okay, what does that must have the same unit mean? So what does unit actually mean? So what does unit mean? A unit is, we all know units because we have all studied units before. So a unit is something like a centimeter, or a meter, or a kilometer, or a liter, or a milliliter, or a kilogram, or a gram, or what else? Or maybe like centimeter squared, mile, inch, feet. All these are units. So when we compare two quantities using the ratio, they must have the same units. So I can't compare two quantities that one of them is a centimeter and the other is a kilometer. It won't be possible because we need the same units. So I can't compare a centimeter to a kilometer, and vice versa. So I can't compare a centimeter to a kilometer, and I can't compare maybe like a liter to a milliliter. They need both to be liters or milliliters, or here they need both to be centimeters or kilometers. So I can't compare two quantities using ratio and they don't have the same unit. No, I have to compare the two quantities using ratio if they have the same unit. So this is property number 3. So what is property number 4? It says the ratio between two quantities. So the ratio between two quantities has no units. What does that mean? We have just said that we have to have the same unit while comparing two quantities using ratio. But what I mean here, don't we, when we write ratio in the past video, have wrote ratio as 3 to 4 like this, or 3 over 4 like this, right? These are the forms of ratio, right? Or 3 to 4 in the form of words, right? These are all the forms of ratio. So the thing is, we need to have, like, we don't have to have units. What I mean is, let me just explain this a little bit more, because it's not actually very obvious to you guys. So I'm gonna change my ink color. Awesome. So when I go, we have always dealt with the ratio in the past video as 3 to 4 like this. We have, so the measuring units. So we are talking a lot about units right now, but we aren't actually exactly sure what are the units. So we have a lot of units that we always use all the time. One of the units is called the measuring units. So the measuring units and their converting rules. So we know the measuring units are the length units. So we know that the measuring units or the length units are the kilometer, the meter, the decimeter, the centimeter, and the millimeter, right? We know these units are the measuring units or the length units. And the area units. So we have now talked about the measuring units, which are the length units. Now we're going to talk about the area units. And you know the area units are always squared, as you can see here, squared, squared, squared. So the area units are measuring units but squared, so kilometer squared, meter squared, decimeter squared, centimeter squared and millimeter squared, and this chart also shows us how to convert them, and we already know the weight units. So the weight units, we know the weight units which we measure weight with, like the ton. You may have not heard about the ton, but the ton is a weight unit that is used to measure very, very heavy things, like big, huge trucks, like cement trucks, like huge rocks and stuff like that. Kilograms, the kilograms, you use them all the time to measure your weight, and grams. And the grams, we use them to weigh very light things like the pencil, the eraser. We use grams to measure these light things, like a leaf or something that is light. So tons, kilograms, and grams are the weight units. So the capacity units. The capacity units are the units used to measure liquids or volumes. Too, capacity is the same as volume, but we almost all the time use capacity for liquids. So the capacity units are liters and milliliters. Liters also, we can say liters. We haven't taken this before, but this is also an info if you want. A liter is a decimeter cubed, and a milliliter is a centimeter cubed. So a milliliter is centimeter cubed, and a liter is a decimeter cubed. And we use the decimeter cubed in case this was volume, and we use the centimeter cube in case this was volume. But here it is not volume. We talk about capacity here. So a liter is a capacity unit, and a milliliter is a capacity unit, and we use liters to measure a capacity unit. Like I have a gallon of milk, I want to see how many liters are there in the gallon of milk, or milliliters to just measure the time units. So the time units are very important. We use them all the time. The time units are the year, the month. The month has 12. The year has 12 months. The week has 7 days. The day has 24 hours. The hour has 60 minutes, and the minute has 60 seconds. So they are year, month, week, day, hour, minute, second. These are the time units. So other units that you may have not heard of before, like cultivated units and money units. We have heard about money units, and we have heard about sometimes cultivated units. So cultivated units are the units used in agriculture. They are used in planting, and they are used by farmers. So they are fedan and kurat and sa. You may have not heard about these before because some countries use them and some countries don't. But a fedan has 24 kurat, and a kurat has 24 sa. So the money units, we have heard them before as a dollar and the cent. Here, just because the book that I'm using has other money units, which are LE and PT, which are used usually in other countries, but we almost all the time use dollars and cents, and the dollar has 100 cents. So example number 1. So we have now experienced a lot of measuring units, and we have now known a lot of things about them. We have known the measuring units, we have known the capacity units, we have known the time units, we have known the weight units. Now let's use the info we have about units and the info we have about ratio to solve this example over here. So find each of the following ratios in the simplest form. And again, if you haven't watched yesterday's video, so go watch it right now. I'm gonna leave a link in the description box below, so because you are gonna need the last video to do this and understand this lesson into the simplest form. So we have talked about this a lot in the past video. So we have here 50 centimeters and 1.5 meters. So first, we can't deal with the same different units. We need to have same units. So we're going to convert the centimeter into a meter, or a meter into the centimeter. I can say that I'm going to convert the meter into the centimeter. So a meter has 100 centimeters. So we're going to multiply 100 by 1.5 meters that we have here, and it's going to be 150 centimeters. Okay, so now we have 50 centimeters to 150 centimeters, and they are both divisible by 10. So 50 divided by 10 is gonna be, let me just change the color so we can see a little bit more. So 50 divided by 10 is 5, and 150 divided by 10 is 15. And now is this ratio in the simplest form? No, it isn't. We need to just simplify it one more time because both of these are divisible by 3, right? So, no, both of these, I'm sorry, both of these are divisible by 5. So here we can divide. So both these here are divisible by 5. So 5 divided by 5 is 1 and 15 divided by 5 is 3. So the answer is going to be 1, 2, 3. So solutions to number 1. So we have done number 1 together. We have not done it all, so I'm gonna finish the rest of them with the answers of the book here. So number B was 350 grams to half a kilogram. So we can't use this different units. We need the same units. So he here converted the kilogram into a gram. So he multiplied by 1,000 because a kilogram has 1,000 grams. It's gonna be 500 grams. It's gonna be 350 grams to 500 grams. It's gonna be 350 to 500 because we canceled the units. And then they both are divisible by 10. It's gonna be 35 and 50. They both are divisible by 5. It's gonna be 7 to 10. The last answer. So we have another one here. So 8 hours to 2 days. So you converted the 2 days to 48 hours by multiplying 2 by 24 because we know that the day has 24 hours and it became 48 hours. So 8 hours to 48 hours, the hours are cancelled out and both of these are divisible by 8. 8 divided by 8 is 1 and 48 divided by 8 is 6. So it's now 1 to 6. Okay, just 1 minute. I'm going to change the color again so I can concentrate in each example on its own. Okay, so let me change the colors. Okay, awesome. So 3 years to 18 months. So we here converted the years to months. He multiplied the 3 by 12 because a year has 12 months. It became 36 months. So 36 months to 18 months. Months are cancelled out. And 36 to 18, they are both divisible by 9. It's going to be 4. It's going to be 2 divided by 2. It's going to be 2 to 1. So here, 1.5 hour to 54 minutes. 1.5 hours converted to 90 minutes, and then 90 minutes to 54 minutes. Then we cancel the minutes out, and both of the numbers 90 and 54 divisible by 9. They became 10 to 6. Both of these are divisible by 2. They became. So remember that. So we have now been talking a lot about ratio, its properties, and we have been talking a lot about the measurements and the units. So now we need to remember some stuff about geometry in the thing because sometimes it gives us some geometric examples and some geometric problems to solve while the ratio to test our understanding to this. And these are some geometric things that you need to remember actually that you have been taught before. So the area of a triangle is always half times the base length times the height. So it's or as letters, it's going to be a times a will equal a, which is the area, will equal half times b, which is the base length, times h, which is the height. So this is the area of the triangle, and then the area of the parallelogram. So the area of the parallelogram is always base times height, or a times bh. Okay, let me change that color again. And the area of the rhombus, it's a little bit tricky. It's the side length times the side length because it has two. One is the side length times the height, and the other is half times the diagonal number 1 times the diagonal number 2. And you might not studied the diagonals before, but it's not a problem. It's not very common. So where D1 and D2 are the lengths of the two diagonals. So we have these three here, and each one of these geometric shapes have its own area formula. So the area of triangle is half base times height. Parallelogram equals base times height, and the so example number 2, and this is based on what we have just talked about in the remember that, which is about geometric problem. It's a geometric problem here, and it's kind of a tricky one because it has a rhombus in it and a triangle, and we might have not had a lot of experience with those, but we're gonna have now. So find the ratio between the area of the rhombus XYZL and the area of the triangle ABC. So we're gonna find the area between both those, the rhombus and the triangle. and we're gonna find the ratio between these areas. So the area of the rhombus, we have to say that it is half diagonal 1 times diagonal 2, or it is, and so we said that the area of the rhombus has two formulas. One of the formulas is half diagonal 1 times diagonal 2, or side length times the height. And here we don't have the side length, or we have the height here. Here is the height, but we don't have the side length, so we're going to use the diagonals. So diagonal number 1 here is 30, and diagonal number 2 is 50, and they're both centimeters. Good, it's easy. So half times diagonal 1 times diagonal 2, which is going to be, let me change the color so you can a little bit more see. So half times 50 times 30 is going to be 750 centimeters squared, because it's area. Don't forget the centimeter squared. So the area of the triangle is always half times base times height, which is half times 0.3. Here is the base, meters times 0.2. Here is the height, which we're gonna convert them to centimeters. We have converted the meters into centimeters because why? Because we have here a centimeter, and we usually convert the bigger unit to the smaller unit. So half times 30 times 20, it's gonna be 300 centimeters squared. So now we have the areas both in the same units, which are centimeters here. So it's easy. We have now followed the property number 3, which while comparing two ratios together, they have to have the same measuring unit, and now they have the same measuring area measuring unit, which is centimeter squared. So the area, the ratio between the rhombus XYZL, which is the antecedent here, and the consequent is the triangle ABC. So the antecedent comes first, which is XYZL, which is 750. It's here, and then the second one, which is the consequent triangle ABC. It is here. It's gonna be second, which is 300. We're gonna cancel the centimeters squared out. 750 and 300 are both divisible by 10. It's gonna be 75 to 30. And 75 and 30 are both divisible by 5, so it's going to be 15 and 6. 15 and 6 are both divisible by 3. It's going to be 5 and 2. So the last one here is 5 and 2. So this is our simplest form, because 5 and 2 we can just convert it into another simpler ratio. So notice that while we're doing this, we have noticed something that is really very important, that people who put the exams or put the lessons, they try sometimes to trick us, giving us different and other, like different and other measuring units, so we can get it wrong. So here, when we dealt with 0.2 meters and 0.3 meters, we have converted the meters unit to centimeters, so it can go by the rhombus, right? Because the rhombus units are centimeters, while the triangle units are meters. So I've converted the meters to centimeters because the meters is the bigger unit, and it's easier to convert the bigger unit to the smaller unit rather than the smaller unit to the bigger unit. So I converted the 0.2 meters and the 0.3 meters to 20 centimeters and 30 centimeters. And this is how we have the same units. And remember, these two properties that I've just taken in the beginning of this video are really very important while dealing with ratio and also proportion, which we're going to study in the second video. I hope, because it's very important actually. So they're important because we have to have the same units. We can't have centimeters and meters. We can't have liters and kilometers. So try these. We have reached the end of this video, guys. Thank you for watching. I hope you learned something new, and if you did, don't forget to hit the like button and hit the subscriber button and turn on the notifications, because we almost have new videos every day and every week if I have some stuff to do. So try by yourself these. They are very basic, like the ones we have just done. But just more with words. They're very easy. If you are not sure what qurats and sahams are still, you can go to the beginning of the video. I have just discussed this, qurats and sahams and kilograms and grams. And these are real good ones to do. So pause the video and do them.